Right, in this week's lab, we're going to be focusing on using modeling in a near real-time context. So the hypothetical scenario that we'll be working with is that we have a camera, and this particular camera has an algorithm on board that takes in the image information from that camera, takes in the number of vertical lines, how bright the image is, all sorts of information, and uses that to estimate the number of individuals that have walked by that camera. So a numeric value that is, 200 people walked by the camera in the last minute. To do this will be a little bit different than we've done before, simply because we'll be having to ping a remote web server that contains the information from the camera. So let's take a look at our Python Jupyter. First and foremost, don't worry about this cell. This cell is here just so that I can make this wider so that you can see all of the code. You'll start here. The first thing that you want to do is this conda install -y anaconda graph viz. Again, I have this commented out. You'll just have to run this once. This will take a few minutes the first time you run it. But what this will allow us to do is a lot of the visualizations we'll want to do later on in this lab. So the first thing that's new here from, in this class is that we actually need to import requests. And we're going to use requests in a different way than we have before. The predominant thing that we're going to do is this post. So what we're doing in this particular line is we're actually putting a live request against an API and getting some form of data back. The elements of this are, first, this is the actual website that we're going to retrieve data from. So obviously you have to specify where does the API that holds the data live. Second, you have to actually ask for the data. The first element of this is an access key. This access key you will be able to get from Blackboard. Right now I just have a filler blank in here. And then you have to tell the API what you actually want to request. So as an example here, we have timestamp start. So the 1st of September 2019 at midnight, and then timestamp end, the 2nd of September at 11:59 p.m. This is defined by the API itself. So this timestamp start and end, what we're saying in this case is give me all of the information from the camera between these two times. Every single API is different. So in the real world, you would have an API reference that gives you information on what you need to put into these particular into this particular field. What are the types of calls that you need to put in? In this exercise, I've just already programmed the API to accept only these two elements, the start and the end. The next thing is the headers. Don't worry about these. These will be unique to every API. We simply have to include these because this is what the API is expecting. The only thing to take note of here is verify equals false. This is a special security setting that we need to put in place for our configuration. This next line here is what actually will read the information that comes back. So here we're going to ping the API. We're going to basically say, here's my password, which is the access key. Here's what I'm asking of from you. So I'm asking for all of the information between September 1st and September 2nd. And then R will be whatever the website gives us back. This interprets R. So this says, okay, take from R the response and then turn it into a pandas data frame. And that we'll call DTA. So I'm going to run this. And again, don't worry about this insecure request warning. This is just the nature of kind of how we've set up our server. And what we want to do now is actually, let's take a look at what we got. Voila. So now we actually have this data frame. And this is what we retrieved from the server based on what we submitted. You'll see a few things. First and foremost is the timestamp. So you'll see the timestamp over here. Every single row of data represents 1 minute of a camera. So we have camera footage from a camera located in the Integrated Science Center at William & Mary. For every single minute, that camera records a number of different kind of features of the image. So these are the convolutional neural network columns. As an example, CNN1 might be the number of vertical lines the camera saw over a given minute. CNN10 might be the number of horizontal lines that a camera saw over a given minute. All the way down to image brightness, which is just literally the intensity of the light for the image. The next thing that we have that we will care about here is the person count. So this is the number of people that the algorithm estimates were there. And this is the algorithm that is on board the camera. What we're going to be doing is we're going to be using these convolutional neural network columns and image brightness to predict person count. We are going to do that first using a historic data set, which is what we just requested, so from September 1st to September 2nd. And then we're going to predict the number of people that are walking by the camera on September 3rd. That's the goal for our exercise. We're going to use a number of different continuous estimation models to do that. And then we're going to pick the best one and select, and then actually apply that in real time. So let's do a couple of things here. First, let's do a matplotlib inline so we can actually see our visualizations. And we're going to import Seaborn. So Seaborn is a visualization suite. You may need to do an installation of Seaborn, but this will allow us to do some quick visualizations and start exploring our data. Let's also just do some very, very basic things. So let's take a look at how much data we just received from this request. Okay, so from this request for these 2 days, we have 2,880 rows of data, where every row of data is 1 minute of a day. So if we do 60 times 24 times 2, that should equal nearly 2880. One thing that's important for us is that we actually want to estimate the minute of a given day. So you can imagine one very kind of immediately obvious thing that we might care about for predicting the number of people that are walking by camera is when the picture was taken. There's absolutely trends regarding how many people are awake and how many people might walk by a camera. So just to illustrate how easy it is to create that type of information, let's do DTA minute. So we're going to create a new column. That's going to equal the timestamp column. So we have this timestamp column right here, which is in a pandas formatted timestamp. We're going to do .dt.minute. And this says this is a timestamp column, a date time column, and we want to get just the minute out of there. Then we're going to do plus DTA timestamp .dt.hour times 60. So that will actually multiply the number of hours in the day, so up to 24 times 60, and add that to minute. And so this way we'll get for every single row the minute of the day that we are currently in. So let's go ahead and run that. And then let's take a look at the correlation matrix. So let's create our correlations. So this is an inbuilt pandas function that will give us our correlation matrix. So I'm going to run this. We'll just run core so we can see a look of what that comes out with. So this is a matrix that allows us to see what those correlations look like. So for example, approach count is perfectly correlated with approach count. The first feature of the convolutional neural net, let's call this straight vertical lines, is not at all correlated with approach count or person count. So on and so forth, right? CNN10 is actually fairly strongly coordinated with person count. So this might be a good one. And we could look across all of these. Now, obviously, this is not a very clean way to look at data. It's hard for us to interpret all of these numbers. And so a heat map is a very easy tool that we can use to make this much more interpretable. So let's go ahead and create that. So we're going to create we're going to use Seaborn to create a heat map. There we go. So now we actually have a heat map that gives us a much quicker way to look and see kind of what's correlated with what. So the thing that we care most about is this person count. So the person count we see is fairly strongly correlated with person count. Of course, male count, image brightness is okay, and then female count. Now, female count and male count, we can't actually use those. Those aren't actually, male count and female count. If we could predict those two, those would add up to person count. So we can't use female count to predict person count because this is not something the camera is giving us. This is something that the algorithm is giving us. So let's do a little bit of cleaning and remove the elements that are not going to be relevant for our analysis, the things that we can't use within our analysis. So things like approach count, for example. We only want to use the inputs the sensor is receiving. So we're going to drop approach count, female count. Now we have a clean data set, and we can do the exact same thing we just did. And we'll do DTA clean. Okay, so here is a slightly refined heat map that's a little bit more effective in terms of what we can actually see. For example, if we're looking through this, we can see that person count is correlated. So we look at person count here. It has some correlation with CNN10, CNN11, CNN12, 3, 6, 9, image brightness, and minute. So all of those might be useful for us to use for our predictions. So essentially what we're going to do is we're going to pick two of those variables to use in our predictive models going forward.